Hello, my dear friends. Welcome to Teacher at Home. Today, class, we are going to learn the second chapter of the chemistry text, that is, elements, compounds, and mixtures. So, first, we can talk about what is matter. We know that all substances in the universe, it is including everything what we are using. What not including everything means living, non-living, everything. It is included in matter, and it is being classified into two categories. That is, matter means that is present everywhere in the universe. It is classified into two types, that is the pure substances and impure substances. We know that pure substances will not be able to get one more substance, but in the impure substances it can be split to in order to get the pure one. Pure substances, same type of particles that cannot be separated into components. I told you, when a substance it is said to be pure, when it cannot be further divided. What are the substances included in that? Elements and compounds. So in the chemistry, we are dealing with the words like atoms, elements, compounds, etc. So first we can talk about elements. Elements are also pure substance. Like a matter, elements also contain what? Pure substance, which cannot be broken down. As a pure substance, pure in the words means it is perfect. So which cannot be further classified or further broken down, nor formed from one or more simple substances. That is, it is already been formed from the simple substances. So it cannot be again formed from what? Simpler substances. It include iodine, lead, aluminium, copper, and oxygen. So under the pure substances come the iodine, lead, aluminium, copper, oxygen. See, these are we using. Aluminium we getting from the earth's crust, we are directly using. Copper also directly using. Oxygen we are used for respiration. The most abundant element in the earth crust. This will be studying in the what? In the social text. Okay. Silicon, aluminium, iron, carbon, everything what is been present abundant in the earth's crust. Hydrogen and helium also is present in stars. It is the shining appearance. Shining appearance of the stars. It is mainly due to the presence of the helium and hydrogen. All substance on the earth, it is also made up of either one or more element. So not only a single element, it is being constituted by a substance. A substance means it consisted of one or more element present in it. It is classified. See, I am taking the class based on your textbook. So whatever the points given in it, it will be given here. At present, 120 elements were known. 92 naturally occurring in earth crust. So out of this 120 elements, 92 it is already been present naturally. Rest only we are artificially created or radioactive elements. Examples of the include solid, liquid, and gaseous elements. So first we can talk about the solid elements. Solid elements constitute what? Gold, silver, iron, copper, lead, aluminium, zinc, sodium, carbon, etc. Liquid elements. Liquid elements it constitute what? Mercury and bromine. That is solid elements it constitutes solid, gold, silver, iron, copper, lead, etc. Liquid elements it constitute mercury. Mercury we see in the thermometer. It will be floating. So it is a liquid. Bromine also it is a liquid, brownish liquid. Then next constitute the gaseous element. Gaseous element means what and all constitute gaseous element? Gas, oxygen, nitrogen, hydrogen, chlorine, fluorine, helium, neon, everything constitutes the gaseous element. So in this first paragraph, we are studying what? Matter. What is matter? That is, all substance in the universe constitute the matter. It is being classified into pure substance and impure substances. Then under the pure substances come the elements and the compounds. So when we are talking about the elements, they are also pure substances which cannot be broken down. Example include the oxygen, lead, copper, aluminium. And the most abundant element in the earth crust, it is the silicon, aluminium, iron, carbon, sodium, and potassium. In the stars, we can see what? Hydrogen and helium. Then everything, already we told now, substance it is made up of what? One or more element present in it. 120 natural elements are known yet. Out of that, 92 it is occurring naturally in earth crust, and rest of it is radioactive elements. Then about the solid, liquid and gas element. Solid elements it include the gold, silver, iron, copper, lead, etc. Liquid elements mercury and bromine. Then gaseous elements means oxygen, nitrogen, hydrogen, chlorine, helium and neon. Next we are talking about the characteristic of elements. So elements, we have told that they are the pure substances. We also talk about the solid, liquid and gaseous elements. Then next we are talking about the characteristic of elements. So talking about the characteristics, what they are also the pure substances. It is made up of only what one kind of particle. So they are the pure substances made up of one kind of particle and exist in three physical states: gas, liquid and solid, occur naturally or prepared artificially. So talking about the elements, they are the pure substances told already, made up of only one kind of particle and it exists in three physical states, that solid, liquid and gases, and occur naturally. So we talked about what 120 elements are there. Out of that, 92 are naturally occurring and rest it is artificially prepared. Classification of elements. So elements are again classified into metals, non-metals, metalloid and noble or inert gas. Then talking about the some words that is being used in the chemistry when we are dealing with the metals. First is the luster. Luster, that is substances having shining appearance. Some metals we can see that they are very shining. Surface shining and the surface lustrous, and they what they will be showing, they will be shining luster, glazing will be there. Then next is the word malleability. Malleability means some metals can be rolled into thin sheets without breaking. That is, when they are being spread into a thin sheet or rolled into a thin sheet, they won't break. Such substances are said to be malleable. So malleability is the process of making the metals into thin sheets without breaking. It includes aluminum, silicon and copper. Aluminum sheets and all uh, we are not about that. Ductility. Ductility, it is drawn into thin wires without breaking a ductile. That is, certain metals can be drawn into thin wires, which are the mainly used one. Copper. Copper, it is mainly used for electrical purposes. It is a thin wire drawn into thin wires. They won't break. Gold, silicon, Au, or Au means aurum. Silicon, cobalt, platinum. Then conductivity. Substances allow heat and electricity to pass through. They are the good conductors. Conductors means when electricity, which allow the metals which allow the electricity to pass through, are known as the good conductors. Include the copper, silicon and aluminum. These are the wires mainly used for electrical purposes. Substances which do not conduct heat, so which conduct are called good conductors, and which do not conduct heat and electricity are called bad conductors or insulators. It includes the wood, rubber and plastic. So which do not conduct electricity are the bad conductors, include the wood, rubber and plastic. Metals. Metals, they are what? Metals are hard solids. We know that it is not able to break. Metals are not able to break. So they are hard solids. Malleable and ductile. Malleable and ductility we already learned. What is that? It can be spread into thin sheets or been rolled into thin wires. They are the malleable and ductile. Lustrous, that is shining appearance, is the lustrous property. High melting and boiling point, good conductors of heat and electricity. Heating capacity it is there, and also are good conductors of electricity. So about talking about the characteristic of elements, we are told that it is the pure substances and it exists in three states, occur naturally or can be prepared artificially. Then the classification, it includes the metals, non-metals, metalloids and noble gas or inert gas. Then first talking about the properties of metals, it includes the lustrous property, malleability and ductility. That is, it can be spread into thin sheets or can be rolled into thin wires. Then about the conductivity, which conductor, metals which conduct heat are good conductors and those which do not conduct heat are bad conductors. Examples are given here. Then first we are talking about the metals. Metals, as we know, it is very hard, not able to break. Then they having the property of malleable and ductile, lustrous property, having high melting and boiling point. Then also certain metals, they are the good conductors of heat and electricity. About the metals. Metals are, see, certain characters we have already discussed. That is about the malleable, ductility property, then good conductors, melting and boiling point. So some other properties include they are the solid at room temperature, except we had seen that mercury in thermometer, it is not a solid, it is a liquid, will be floating. So when we are taking our body temperature, it will be floating. So uh, these metals, they are certain only are a solid at this room temperature. Silver, gold, platinum, zinc and tin. Sodium metal is soft. So one of the metal which is soft, it is sodium. It will be able to cut with our knife. Silvery color loses luster when reacts with air. So what is the peculiarity of sodium? It is having the silvery color and loses the luster. Luster when reacts with air. When reacts with air means sodium, it forms oxide. Oxygen. When it is contact with oxygen, it forms oxide. Then non-metals. Talking about the non-metals, they are the dull surface. Metals are having the hard surface. Non-metals are having the dull surface. Except graphite and iodine, they are having the shiny appearance. Non-malleable and ductile. This property already we had studied. So non-metals, they are not malleable and ductile, not able to spread into thin sheets or wires, and they are having the low melting and boiling point, bad conductors. So what are the properties that is given in the metals? The reverse it is being seen, reverse is being seen in where? In non-metals. Non-metal, they conduct a heat and electricity. That is, it is given in exceptional case. Exceptional case is graphite, mainly solid or gases. They exist in three states. But bromine is a liquid. Hydrogen, that is the lightest element. Oxygen, sulfur and nitrogen. Copper was the first metal used for making utensils, hence known as. So in the 4000 BC, they were using the metal. First metal used was copper. That is that period. It is known as the Copper Age. Then when we compare about the characteristics of metals and non-metals, first we can see the shining appearance. Metals, they are having the shining appearance. That is sodium, it is having shiny luster, whereas compared to the non-metals, it is having the dull surface. Except that is exceptional case will be there. That is in the graphite and iodine. Then about the high density comparing, metals will be having the high density. Non-metals, they are having the low density, and melting and boiling point, it is high in the case of metals, whereas low in the case of non-metals. Then they are ductile and malleable, whereas in the non-metals they are non-ductile and non-malleable. Then the good conductors of heat and electricity, whereas non-metals, they are not the conductors of heat and electricity. So here we learned about the two more peculiar characteristic of solids. That is, they are soft, able to cut. Then they are appearing in the solid and also in the liquid state. Comparing to the non-metals, that is comparison, it is given in the given here. Comparison means they are the non-metals, they are having the dull surface, non-malleable, non-ductile, low melting and boiling point, then bad conductors. These are the characteristics of non-metals. Then about the copper age, that is the copper was the first metal that is used in the 4000 BC. So hence that age it is known as the copper age. Then talking about the metalloids, that is between the metals and metalloids are metals and non-metals is the metalloid. Till now we talk about the metals, non-metals, their characteristics. Now we are talking about the metalloids. That is lying between the metals and non-metals are the metalloids. They show property, that is what some extend to that of the metallic and also the non-metallic. They are because it is lying between the metals and non-metals. It includes the boron, silicon, germanium and arsenic. So metalloids come under boron, silicon, germanium, arsenic. Then coming next, it is the noble or the inert gas. Noble or the inert gas, as the word itself represent, they are the gaseous element. They do not react chemically with other elements. Hence they are stable. The mainly commonly occurring inert gas are the helium, neon, argon, krypton, xenon, radon. Discovery of electron. So some of the scientists and their discoveries, it is been given here. Electron, it is discovered by J.J. Thomson. Proton in the nucleus by Goldstein, and neutron in the nucleus of atom also been identified. So we have talked about metals, non-metals, then metalloids. Metalloids lie between that of metals and non-metals. Then it is having show property of metallic and non-metallic. Then next it is the noble and the inert gas, which include the gaseous elements. That is, they do not react with other elements, hence they are stable. When we are reacting with other elements, stability slowly decreases. So hence they are stable. It includes the helium, neon, argon, krypton, xenon, radon. Discovery of electron, it is by J.J. Thomson, and that of the proton in the nucleus by Goldstein. Next is the most important topic in the chemistry, that is the symbol of elements. It is the base. Without knowing that, we will not be able to study this chemistry. So Swedish scientist J.J. Berzelius developed the symbols used today. So what the symbols we are using today? That is the first name of the element. It is been invented by the Swedish chemist Berzelius. System of determining symbols. How to determine the symbols? That is, for non-metals, use the first letter of English name. First letter means hydrogen, boron, see here, B, carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur and iodine. So we are using the first letter for the non-metals. If element having the same initial, second letter it is taken. So when we are taking an element, if the first letter it is already been occupied, we are using the second small letter, it is been taken. Gallium. Gallium, we are see the G, it is has already been taken. We are taking it as Ga. They do not occur naturally. Brittle solid, low temperature. So gallium, it is not occurring naturally. It is a solid at a low temperature and liquefies above room temperature. So when above room temperature, it get about liquefied. The solid starts liquefying. It melt in hand. So these are the peculiarities of gallium. That is, here we are studying about the symbol of elements. For naming an element, first letter we are taking, first capital letter it is taking. If this letter it is already been occupied, we are taking the next following letter, small letter it is we are taking. Then talking about the element gallium. Gallium, it is a soft element. Then it is brittle soft at low temperature and liquefies above room temperature. It easily melts in hand. The next metal, it is the gold. Gold, it is having the certain properties, that is the shiny colored yellow metallic element. Unreactive metal, that is it does not react with any other metal present. So do not form compounds. As it is not reacting with any metals, it does not form what? Compounds. Okay. Then keep its attractive and shiny appearance for making jewelry and ornaments and does not tarnish in air or water. So what are the peculiarities of gold? We already know that it is having the shiny appearance and the color of it is yellow. Then it is an unreactive metal, that is it does not react with other metals. That is the main property of gold. So it does not form compounds and keep its attractive and shiny appearance, that is for used for making the jewelry and also ornaments. Does not tarnish in air. It is not easily destroyed in air or water. Then next element is that of the chlorine. It is a greenish yellow gas. Chlorine, it exists as a gas. It is a greenish yellow in color. Irritates the eye and throat. So when we are in contact with the chlorine gas, it what we feel irritating. Our eyes will be feeling irritated and also the throat. It is poisonous in nature. And what? Manufacture of insecticides, purification of water. So the main purpose of chlorine, it is used for the purification of water, manufacture of insecticides, and it is what is the peculiarity? It is having the poisonous nature and irritates the eyes and throat. So these are the this all included in chlorine. It is a gas, greenish yellow in color, irritates the eye and throat, poisonous in nature. Then it is used in the manufacture of insecticides and also for purification of water. If the first two letters already occupied, then the upcoming consonants, that is in the case of magnesium, sodium, Latin words are also used. Then helium, see, consider helium, Helium. So we are using what? H means it is hydrogen already occupied. So what we are using? We are using He, that is helium. Then next, talking about magnesium. Ma, it is already been occupied. So the next upcoming letter, that is Mg, it is used. In the same condition, same case, manganese, Mn, chlorine, Cl, chromium, Cr. Some having Latin names, that is some elements will be having their Latin names. Include natrium, ferrum, argentum. Then alchemist symbol. So first we are not using these letters, but first we are using symbols. See here, this triangle represents the fire and this symbol represents the water. So many other symbols are being given in your textbook. You have to read that. So I have written only these two symbols. So here we are talking about what? Gold, chlorine, then then the symbols used in the ancient time. And John Dalton's symbol, what is it include? What is that represents? You see here the circle with one dot, hydrogen, carbon, oxygen. It is a circle with C, copper, I, iron, sulfur, lead, and gold. So these are the symbols used by the John Dalton. And alchemy symbol, it represents that triangle for fire and the symbol for water. Many other symbols are also given in your textbook. Then next, talking about the inert gas. So how to represent the inert gas? See here, first one, it is helium. Helium. So the first letter followed by the small initial letter, it is also taken, helium. Next one is the helium neon. Ne, argon Ar, krypton Kr, xenon Zd, Xe and radon Rn. So this has been represented in inert gas. Then the representation for some other metals are also given. See here, element aluminium. This all we have to learn it. That is only by practicing we will be able to understand the symbols used for each element. See here, the first one is the aluminium. Al, calcium, Ca, copper, Cu. That is, it is having some other Latin names. Copper in the sense cupra, gold, Au, aurum. Okay, so for certain elements, they are giving the Latin names. For certain elements, they are giving the first letter. For certain one, they are giving the first letter followed by the second initial. Then iron Fe, lead Pb, plumbum, magnesium Mg, mercury hydrogenium Hg, potassium K, calcium, platinum Pt, sodium Na, natrium, silver argentum Ag, zinc Zn, bromine Br, carbon C, chlorine Cl, hydrogen H, iodine I, nitrogen N, oxygen O, phosphorus P, silicon Si, nitrogen N. So this you have to note down, or you have to write or read many times. After that only you will be able to get the symbols of each element. See here, one more time I will read. Aluminium Al, it is used. Calcium Ca, copper cuprum, that is the Latin name Cu, gold aurum Au, iron ferrum Fe, lead plumbum Pb, magnesium Mg, mercury hydrogenium Hg, potassium kalium K, platinum Pt, sodium Na, natrium, silver Ag, argentum, zinc Zn, bromine Br, chlorine Cl, carbon C, hydrogen H, iodine I, nitrogen N, oxygen O, phosphorus P, silicon Si, nitrogen. So, some elements we after reading one or more, two times will be able to understand. Some elements whose symbols are the first letter. For certain elements we are using the first letter. For example, the sulfur we are using S, boron B, iodine I, oxygen O, nitrogen N and fluorine F. Symbols with the first two letters. For certain elements, I had already told that first two letters are being used. That is in the case of aluminium, Al, silicon Si, argon Ar, bismuth Bi, cobalt Co, magnesium Mg. This video, if you are repeatedly seeing one or two times, you will be able to get practice. Symbols with Latin names. So, First element, it is the sodium, natrium, Na, copper, Cu, cuprum, silver, argentum, Ag, mercury, hydrogen, Hg, potassium, K, calcium, iron, Fe, ferrum, lead, Pb, plumbum. So these are the letters or symbols that is being used in elements. So some elements we are using the first letter, some first followed by the second letter, and for the third one we are using the Latin names. In the universe, the main elements, the main constituent, it is the hydrogen and the helium. That is being present in the universe. In the earth crust, we can see oxygen. That is the greatest amount. Everyone using oxygen for the respiration. So it will be present in the great amount. It is followed by silicon, aluminium and iron. In the atmosphere, nitrogen is the most abundant element. So around 78% it is constitutes the nitrogen in the atmosphere. Only 21% it constitutes the oxygen. But oxygen it is being used by the consumption for respiration. And in the universe we can see the major quantity of hydrogen and helium. In the earth crust, oxygen. In the atmosphere, nitrogen. So you have to classify this. Human body consists of carbon, hydrogen and oxygen. They are made up of compounds in all the bodies. So our body, it is made up of many compounds. In each compounds, what are the elements present? It is the hydrogen, oxygen and carbon. Compounds. What are compounds? Pure substances formed when two or more elements combine together. So element, it is a pure substance made up of only one substance, whereas compound, it is formed by the combination of one or more elements chemically together in fixed proportion. They are not gathered as such. They are being formed in fixed proportion by weight. They form a compound. For example, there are certain examples given here. So we had to learn that compound is a pure substance. In the same way, elements are also pure substance. Elements, it is formed by only one substance, okay, whereas compound, it is formed by the combination of one or more elements combined together. They are not combined as such, they are combined in a fixed proportion by weight. For example, salt. Salt, it is a combination of sodium and chloride element or chlorine element. So sodium, how does it exist? It exists in the solid form. And so chlorine, it exists in the gas form. So this solid and the gas, it combine together or mix together to form salt what we are using today. Okay, salt means sodium chloride. It is formed by the combination of solid sodium and gaseous chlorine. Same way, the most common substance, it is the water. That is the main source of every living creature. Water, it is not as such as a water. It is by the combination of hydrogen and oxygen. Here we can see that hydrogen and oxygen both are gas. In the previous case, we have seen a gas and a solid, but here the two gas combine together to form a liquid what we are using for drinking and every purposes, that is water. Then next one, it is the sugar. Sugar, it is the combination of hydrogen, oxygen and carbon. When they are combined in a required proportion, we get what we are using as sugar. That is these three components. They are the gas. Hydrogen exists as a gas, oxygen exists as a gas and carbon exists as a gas. Compounds have properties which are completely different from the property. That is, we all know that because compounds are formed by the combination of two elements. So these two elements will be having two properties. These two properties combine together to form what? Compounds. Any different proportion. Sodium chloride totally different from sodium and chlorine. We know that sodium chloride, it is a combination of solid and gas. That is, physically itself is different and the properties also will be different. So in this we studied about the common elements that is being used in the universe, earth crust and also in the atmosphere. So what are the elements that is found abundant? In the earth crust it is found as oxygen, in the atmosphere as nitrogen and in the human body it is carbon, hydrogen and oxygen. Then about the compounds. Compounds means they are also pure substances compared to that of elements, but it is formed as a combination of two elements when combined together to in a fixed proportion they form the compound. We have given the examples. What are the examples used? That is, the salt, water and the sugar are the examples we have taken. Salt is a combination of sodium and chlorine. Water is a combination of hydrogen and oxygen. And sugar is a combination of hydrogen, oxygen and carbon. In fixed proportion by weight, they form the sugar. Then next about the characteristics of compounds. So till now we have talked about the what are compounds, how it is formed, etc. Then coming to the characteristic of compounds, they are the pure substances having the same composition and properties as and they are homogeneous. Same in the same meaning homo. Okay, genius, that is as they are the pure substance, only impure substances will be having different properties. Pure substances, these properties and composition will be the same. Distinct properties in which the original components lose their individual properties. Energy is released or absorbed during the formation. So when a compound it is formed, as certain examples we have already seen, the salt, sugar. Here in that case, what is seen it is, in some cases the energy will be released or some energy will be absorbed to form a compound. Elements in a compound cannot be separated by physical means. Iron cannot be separated from iron sulfide using a magnet. See, in order to separate the iron from soil, we usually use a magnet. But the same procedure cannot be used for the separation of iron from iron sulfide. It is talking about the characteristic of compounds. So they are the pure substances having the same physical and composition and properties, hence referred to as homogeneous. Then in this process, that is in the formation, energy will be sometimes released or absorbed. Energy will be released or absorbed. Then elements in a compound cannot be separated by physical method. That is, a certain physical method can be applied for obtaining certain compounds, but for in the compounds, but cannot be applied for all. In the case, iron can be separated from the soil using a magnet, but it cannot be used in order to separate from iron sulfide. Then talking about the atoms and Talking about the atoms and molecules. Atoms are the smallest particle. This is the first word that is we are used in the chemistry. Atoms means they are the smallest particle of element. All properties, smallest particle of elements means it possesses all the properties of elements. Helium gas, it is made up of helium atom. So atom, as we seen, it is the smallest particle of an element. It cannot be split into again. That is the smallest particle ever seen. It is the atom, which cannot be further divided. And what it possesses? It possesses the properties of elements. For example, they are giving the helium gas. Helium gas, it is made up of what? Helium atoms. Characteristics. They are very reactive and does not exist as free atoms. Atoms of one element are alike. They differ in properties. Properties. What are the properties in which they will be different? In the shape, size and mass. Atom maintain its properties through physical and chemical changes. So these are the characteristics of atoms. Characteristics include there does not occur free atoms, and they are very reactive. Atom of one element will be alike and different properties. What in which all properties they will be differed? They will be differed in shape, size and mass. And they maintain the property through the physical and the chemical changes. Molecules, smallest particle of an element or compound. That is, molecule means oxygen gas. It is made up of oxygen molecules. Molecule means smallest particle of an element. So atom is the very smallest particle. Molecule means of the element and compound, they are the smallest particle. In the case of oxygen gas, it is made up of oxygen atoms. Then about the characteristics of molecule. Molecule of a compound has atoms of different elements combined in a fixed ratio. They are formed by the combination of atoms of same element or different elements. So how a molecule is formed? It is atom of same element or different elements means in the for example water, it is formed by the combination of two hydrogen and one oxygen atom. So the atoms of different elements in a fixed ratio, in certain ratio, certain elements combine together to form molecule. held together. So this has to be held together by a certain force or certain bond. They are known as the chemical bonds, represented by molecular formula that is being used for the molecules. Molecules has to be represented by their molecular formula. Here energy it is either absorbed or evolved. In order to form the formation of a compound, energy it is either absorbed or given out. So talking about the characteristics of molecules, they are also what molecule of a compound means. It is formed from different elements in a fixed ratio. They are being held together by certain bonds, certain forces. They have to be held together, and they are represented by this molecules has to be represented by certain molecular formula. Here the energy it is either absorbed or evolved. Then about the atomic structure. Atoms are fundamental building blocks of chemistry. Atoms are the main word which is being used in chemistry. Atomic structure means each atom will be possess certain structures. Internal structure in atoms, particular chemical elements differ from. That is, one element will not be exactly that of the other element. They will be entirely different. The structure also will be different. There will be variation in the chemical behavior also. Talking about the ball and the stick model, that is here the ball and a stick, it represents the structure that is being used in the chemistry. Bonds, so certain bonds has to be fixed, certain forces or bonds has to be fixed in order to keep the molecule in position. Spheres connected by spores, for example hydrogen. H2 means two molecules of hydrogen. It is being combined by a bond. See here, ball, this is a ball and this one is the stick. This is the stick and this one is the ball. So here represent the stick and a ball for in the case of hydrogen. For oxygen, O2, that is a double bond it is used. Two balls are being connected by two sticks. In the case of nitrogen, triple bond it is being formed. That is, two balls had been connected by three sticks. So the molecular formula, molecular structure will be entirely different form for each element, for each molecule. That is being represented by bonds. That is structure of atoms. Atoms, it contains what? Contain core, that is the nucleus. A nucleus, it is being split, that is it is been classified into protons, neutrons. That is in the inside the atoms we see the nucleus. Nucleus, it consisted of the protons, that is positively charged, and the neutrons which is possessing no charge. It is also having a negatively charged particle, that is the electron. So atoms contain what? Nucleus, protons, neutrons and electrons. Inside the nucleus, we can see the protons and neutrons. Protons, it is having the positive charge. Neutrons, it is having no charge. And electrons, it is having negative charge. See here, this represents the orbit in which the electron it is being revolving. So the electrons are arranged in a fixed place, that it will be revolving around the nucleus. As a planet revolving around the sun, the electrons will be revolving in an orbit in the nucleus. See here, this represents the orbit. Then what is the difference between the atom and the molecule? See, this is the structure, the electronic configuration we'll be studying in the later classes. Difference between the atom and the molecules. Atom, it is the smallest particle of an element. Molecule, it is formed by the combination of two or more atoms combined together to form the molecule. Atoms consist of nucleus, that is proton, neutron and electrons. Two or more like or different atoms chemically bond together. Not the like only, but different atoms will be bound by a chemical bond. It is seen through the naked eye or microscope, and not seen or naked eye but by highly magnifying microscope. That is, atoms can be seen through the microscope and also through the naked eye, but molecule cannot be seen through the naked eye. Only highly magnifying microscope can be seen. It cannot be further divided into individual atoms. That is, atom, it is the smallest particle, cannot be again further divided, but molecule can be further divided. May or may not have independent existence. That is, oxygen, it exists like this, atoms, and here the existence is oxygen molecule. Nuclear bond. So they are held together by the nuclear bond. Involves what? Electrostatic attraction between the nucleus. Here the chemical attraction or the bonding between the atoms involves single. That is bonds involved here. It is single, double and triple bond, and it has been held together by the chemical bond.